Hello everyone and welcome to another episode of No Orientation Programming. I'm Joe and today we will hopefully connect to our gaming server today. Today's stream is in English again, so let's see. The first thing I want to do is something quite nasty, and that is changing a core function. Let's see. Arc repel. Yes, we have the repel function used in the testing application. So this means we can check if we are using this function in the interactive testing process. P-admin repel. So this is an admin interacting pointer. And I want to repel. I want to rename this function to internal repel. And then we need something else, of course. We need to define a macro P for process, whatever, and then we say we make a cast processing point to a processing pointer reference, and here we say we have a processing pointer reference, and then we can return null and say pchild is null. Let's see if this is working. Oi, oi, oi. System debugging. Okay, useless cast. Oh, that's so bad. We don't have any. Yes, we need this, of course. So at least one error is. Oh yes, okay, then we have the useless cast thing. Okay. I thought this is a quick. This is going to be quick, so. Then let us connect to the server. We have, hopefully the server is not is running, still running. USDO. Yes, the server is still running. We have 27 bots connected to it. And now we want to connect through our testing application. The testing application admin interacting, and we have menu interfacing. Okay, the default values for the testing are, we want to create one connection which is sending data, in a 200 milliseconds interval. And then if we press S, then we have this event to the main process, TGS interactive testing. Okay, so we created a communication testing process already, and now we can connect to our server. We have to, yes, at first we will make the internal code, that is in the TGS interactive testing we are processing the admin admin events like this, and this means we need the header file TGS interactive testing, and we want to include com testing, and we want to create a list, a vector or a list. And let's say we have an std vector. Yes, why not? Of com testing pointers. List com communication connection. Let's call this event com instead of con for general communication testing. Okay, so we say if dot size, if we don't have a size, then we create, let's make help functions. Com create otherwise com delete. Delete. So then we have com delete, and we will place it underneath admin remove. Yes, how many should we create? Yes, we say count and interval. This means com create has uint count and uint interval ms message count as your integer. Is equal to message interval ms as your integer. And then we say count in interval ms. Almost. Okay. Perfect. This should compile. Unused parameter. Yes, of course, it's not compiling. Void count. Now it is compiling, that's fine. Okay, so if we say a vector of TgesTesting pointers, iterator iter is equal to list compound begin for iter not equal to and plus plus iter, we say p com is equal to iter repel pcom. So we are repelling our our communication testing processes. I think that's all we have to do. That this means I will make it a little bit shorter, because then we say clear, and in this case we say no, we don't need this pcom. Okay, so we say reserve count, and then we say I equals 0, I smaller than count, and plus plus I. We say pcom is equal to TgesTesting create pcom. Stop. If not, pcom could not create process. And then we say mcount is equal to count. No, we don't need this. M interval ms is equal to interval ms, and then we say should we start the process immediately? Start pcom. And then we say mlist communication pushback pcom. What if we if one failed? Then just make the other. We say continue. I think that's good enough. Proc warning log. Could not create process. So if not size, then create. We make a size. If size, then delete, and we remove the size. Yes, I think we should see. Yes, of course, we have to make a new integer interval ms. The default intervals should be 100 or something. Okay, this worked. And now we should be able to see multiple communication processes as soon as we start. This is not the expected behavior. Okay. Count connections. Why? Com delete. Type is com. Let's see. Debugging with logs, that's the best thing ever. Okay, com create. Let's make a more verbose log output. Processing, starting com testing, initialize not use processing. Oh yes, I understand. Easy. Okay. So because start, if we want to make this visible, we have to, oh come on, So we don't need a verbose output because now we should see. Yes, we have one COM testing process, perfect. And then if we press S again, it is repelled. If we press S again, it's here. And then it's, that's cool. That's very cool. And in which state? We are in state start, perfect. Okay, yeah, that's cool, that's very cool. Okay. So now we want to create a testing, a TCP transferring process. We say TCP transferring, and then we say mpcon state is null. So we have included, initialized, and then we say oh, come on. Always something must be. Main and start. Okay, so Vim tools CPP processing, yes, because this is bad. And now we try to test this thing. CPP processing test. So now we have a testing CPP. Okay, and this seems to be fine. Now, okay. Perfect. Now start. We need a new state that is TCP con create. Okay, here we say state is equal to this one. mpcon is equal to TCP transferring create. Could not create process, that's perfect. Otherwise, go to con send ready wait. Oh, come on. So that's good enough. So start mpcon and then mstate is equal to send ready wait. If mpcon ready send ready, if not, ready to then break, otherwise main, I don't know. Go to m state is equal to state main. Okay. Okay, the TCP transferring needs something. That's in the core. TCP transferring has two create functions. We have a file descriptor or we have a host address and a port. Yes. Const string reference and you integer 16. Okay, this means we have yes, that's fine. And port is equal to the telnet port. And telnet, the port is 23. And then send, yes, send. It's a transferring, and the transferring process has, I think, send ready. We create the connection, connect to an IP, start the connection process, wait until it's ready to send, and we go to main. Let's see if this is working. Let's connect to our server. Oh no, oh yes, stop. We don't want to connect to the official server now. We don't want to do, we just want localhost. Yeah. Okay. That's way better. And we want to, this has a different port, that's 4000. Build native, Ninja, oh come on, telnet, yes, that's fine. Hopefully it's compiling, yes, it's compiling, that's fine. But now we need to connect to telnet localhost 4000. Yes, we have one guest, that's, this is this connection. We can refresh, and now we can create yes, yeah, now we have two guests. Perfect. We are in the main state of the communication testing, and this is, that's perfect. That's cool. Okay. So we don't call this a state main. We make two states, that is state data send and state wait data wait. And we go to the state data send. And here we go to data weight. Ooh, yes. I want two other things in the template. It's annoying. Tools CPP processing, and that is I want to have the m.ms thing here initialized to 0, and I want this integer here. Come on. Initialized may be used, but at least existent. Yes, that's fine. Perfect. Okay, then we check these two things and we say before we enter a wait state, we say similis. And then we say data weight if diff ms is smaller than interval ms, we break, otherwise we go to data send. So send ready wait, we go to data send. Data send is sending the data. That's it. Was not declared. Data wait, send, wait, send, wait, send. Oh, that's perfect. Wireshark. That's the loopback thing, and we say tcp.port is equal to 4000. Let's make a bigger interval of 1000 for one moment. And we need a send function. What should we send to mpcon? mpcon we send, I think we need a data pointer here somehow. We say r and 1. Is this possible? Not quite what I expected, but okay, let's make a pause and then continue. Zack, zack, zack. And as soon as I hit S again, it should stop. Okay, so what do we have here? We have what's that? Ah, okay, I think that's the first. Yes, we have 1 data byte. R. And then we have welcome to the terminal game server. Yes, that's it. I think this is it. Okay, cool. So now, next step. Connection, yeah, okay, fine. We make a split. And we connect to the server, telnet localhost 4000. Now we have 1 guest. We connect to NC localhost 3000. That's the, yes, that's our server. Gamers. Oh, okay. Some bot connected, but that's okay. Now we should be able to. If I press S, then we have 3. If I press S again, we have 2. Here, this is refreshed all the time. Okay. That's cool. Now I want to try 5 connections. Oh no. 5 connections, and an interval of 200. 5 connections, terminal filtering. Could not connect to host. Why? Consent ready wait. Interesting. Let's see what is happening here. Yeah. A lot more communication. But still strange. Why is this happening? Couldn't connect to host. Again, the last one. Come on. What is happening again? Please. Could not connect to host. Oh my god. This is not the 5th one. Okay. This looks like an initializing issue again. What is Oh, that's interesting. Gamer. Oh, no. Oh, okay. Okay, because I'm administrator, I have this strange name. Okay, I was confused now. Okay. But still, okay. We get an error. Could not connect to host. Maybe we have a bug in the TCP transferring process. Could not connect to host. Timeout could not connect to host. And there is no error. We see that we have no error message. That is very likely. Okay, let's add the error number itself, num_error. $114. What? Connect error 114. Man, connect. Linux error codes. Maybe the error is somewhere else. Result. Connection done, wait. $114. Operation already in progress. What? How is this possible? State is client start. Server start, client start. Invalid socket. Let's see if we have initialized everything we need. State. For this type. State. Start MS. Socket. Port. Error host port error number. error number usable. Usable is not used. Okay. Info set, bytes received and sent. Send ready false. Con main. Con done wait. We are waiting multiple times. Yes. Okay. I understand. I understand. Yes, that's okay. Or is it? Is it? I don't know. We have one error. Okay. If what's the return value of this thing? Return value. If the binary 0 is returned, one error minus 1 is returned. If we have to say if res smaller than 0, then else num error is 0. If not res, error is 0. Otherwise, okay, let's see what's happening now. That's strange. 114. Operation already in progress. Maybe this is just, yes. This is just another. I don't know. Should we? Error number. This is way better. Yes, that's better. 5. Oh yes. Yes, this is fine, I think. Let's check the trace. Stop it. Stop this here. So we have a change in the TCP transferring thing. That's very, very important. I don't want to have. Oh, yes, I want to have, yes. So I think that's fine. Now I have to think about a useful commit message, because this is the processing core. Continue on despite good enough, I think. Processing core, that's fine. So now we can connect with more than 4 processes. That's cool. Now we have 6. And let's try to send faster. So this is the cycle time in milliseconds, and now we check how many connections we can make. In this case we have 1, 2, 3, 4. 1, 2, 3, 4, 5 different connections. That's perfect. And that's an acknowledge. You have to be careful. That's an acknowledge. That's data 30, 42, 54, 60. 68. Is 68 sending something? Yes. That's an R. Okay, perfect. Now let's stop it. Let's create 10. Now we have 11. That makes sense. Okay. Stop it. Let's make 20. We will increase the number. Oh, it's slowly, it's going up very slowly. And we will increase the number of connections. Let's check in the other terminal if we can still. Oh, I have to do this now. This is so annoying. TGS main message dispatching off. Connect. Oh, we are writing in the log. Let's not do this. Velocity 0. Oh yeah, I was waiting for some output. Okay. Connection error occurred. Yes. Let's stop it. And yes, if the connection, if we have a connection error, then the contesting should if mpcon and mpcon success not pending, return positive. We should have something similar in this, in the game injecting process. MP filled or con MP field and MP field unequal to pending, then return positive. Yes, that's cool. Let's try this out because we make two connections. What's that? Oh, I understand. Yes. Okay. And now we stop the server. TCP transferring connection error occurred. Let's stop it again and start the server. Start the connections. Stop the server. Yes, we have a connection is down. That's fine. But still, did I recompile? No, I was not recompiling this thing. Let's try again. Starting and stopping the server. Connection error occurred and com testing is finished, but we are not repelling it automatically. Yes, we should. In the interactive, okay, in the interactive, com create, com delete, com clean up. Let's call it com cleanup. Like this. I don't know. I don't know if this is cool, but let's try it out. We have com testing pointer, pcom communication. Yes, fine. In the main thing we say if something, then com cleanup. If we have something in the list, com size. Done check. Let's not call it cleanup, but done check. So yes, okay, fine. Pcom is equal to iter. Success is equal to pcom success. Success. Okay. If success come on is not is equal to pending. Continue. One, two, three. Yes. Okay, fine. If then we repel the P communication and we say iter is equal to mlist.com dot erase iter. Let's check if this is making any sense. So we have no, oh damn it. Oh, segmentation fault. That's interesting. Could not connect to host. Yes. Okay. Fine. Pcom gets repelled, and then I think maybe this is the. Let's check this out. Continue. This should be possible. Ah, no. This is not. Oh. We have to, yes. While iter is not equal to this, and otherwise plus iter. That's it. Hopefully. Yes. Could not connect to host. That's fine. Okay, now we create two. We have two processes, that's fine. Now we disconnect and cleaned up, and we try again. We were able to see the two processes temporarily trying to connect to the host, but then we had an error because the host is down. The service is down, yes, and then we do it again. So, yes, that's exactly what I want to see. Okay, so now let's connect here to the server again. We have two connections, fine. We stop the connections, fine. We make 20 connections with an interval of 200 milliseconds. Let's make 100 milliseconds. And the menu interfacing, we say 105 connections minimum. Yes. Let's start 20 processes. Let's create something. Yes, we can create a Connect 4 game immediately and then press enter. Yeah, seems to be fine at the moment. Cool. We stop the connections. We increase the number by the power of 2. $33. That's taking quite long. 38, okay. Let's create the game again. Oh, we have 42. Some of the processes need a lot of time to connect. Okay, let's see. Let's create the game again. And oh, gamers. Connection down. Removed. Who is removing the connections? Connection down, error occurred. Yes. Okay, I see. It's too fast. That's too far. Uh-huh. I think this message is only visible if we have multiple bytes in the buffer. And this is not allowed in the server. Okay, let's try to increase the interval. A little bit. Like 1000 again. It's doesn't matter at the moment. 40 connections. Starting. Create the game. Test. Mm-hmm. We have 41 connections as expected. We can still play a game normally. Cool. That's fine. I will stop the connections. I will stop the server. One connection again. Fine. 80 connections. Starting. What if I connect now? Immediately. No error at the moment. 41. 80 connections should be. We should have 80 connections. Conveyed. $45, okay. Why is this taking so long? Although I can connect immediately. 44, 45, 44, 45. Can create the server. Why? Do I have some sort of restriction somewhere? What is happening in the trace? Maybe the problem is that I have to do something if... maybe. Maybe I have to do something else in the connection state. This seems to be something operation now in process, already in process. The socket is non-blocking and the previous connection attempt has not yet been completed. The socket is non-blocking and the connection cannot be completed immediately. Let's check. E in. We have Win. Oh, yes. E in progress and come on. Fucking. Ah! Ah, fucking mosquitoes. Okay. No support. E again for not blocking domain. Yes. The socket is non-blocking and the connection cannot be completed immediately. For other socket families, there are insufficient entries in the routing cache. Okay. E in progress. We have the socket is non-blocking and the connection cannot be completed immediately. Unix domain sockets failed with E again instead. It is possible to select a poll for completion by selecting the socket for writing. After select indicates writability, use get socket opt to read the SOR option at level SOL socket to determine whether connect completed successfully. We have already the socket is non-blocking and the previous connection time has not been yet completed. I have an idea. I want to see the connections. Yes. One moment. Okay. We have in the interactive testing, we have start. We set the visibility in the tree to true in for the connection process, and our own visibility we set if thanks for the follower. As soon as we have connected successfully, we remove ourselves. Hi, Kush Bramhead. Kush Bramhead. How is it going? What's up? Nice to see you. So let's see if this is working. We try to make 5 connections. And let's do something else as well. That is, we want to see how many connections we have started. In the TGS interactive testing process, we say number con count, whatever, u, and that is list com dot size. How many connection processes do we have in the list? I want to see it because now we, oh come on, you expect the argument of time and arms length but has size t. Yes, fine. Actually, I still don't know. Printf size t. Size t. ZU. Okay. Going good, but I'm confused what to do. My colleague is teaching programming languages. My college is teaching programming languages, which I don't want to make in career in that all. I wanna make career in full stack web developer, but my college is teaching Oracle SQL database and some old technologies. What should I do? College, this means you're between 15 and 20, I guess. I would say just try to learn it, because it's fine. You need a lot of understanding if you want to have a job in as a full stack web dev. Full stack means in this case you are able to make front end stuff and back end stuff. This means the visualization stuff and also the stuff that is going on behind the scenes. So it's fine to learn as much stuff as possible. I'm 20 years old and took admission in MSc IT Master of Science in Information Technology. Yeah, that's cool. I completed my Bachelor's of Computer Application. Cool. Yes, so you're already bachelor. Okay, cool. Yes, Oracle SQL database and some more techniques. Actually, I'm not that into the web section. So my competence is not the web stuff. But so I can't even tell you if Oracle SQL stuff is relevant today. I think it is. Popular databases. Most popular databases. Number 1, Oracle. So it seems to be relevant, and so seems to be fine in my opinion. So it can't hurt, at least it can't hurt to learn about this database stuff. I thought it was MongoDB. Yes, no. I searched this list a couple of days ago, and I was surprised that it's still Oracle, but yes, we have MongoDB here. It's in the Postgre. I'm using Postgre for the wiki, for example, and so I had to deal with some Postgre SQL stuff, but actually it's fine if you learn database stuff, SQL stuff. It's cool, and I think as a full stack web dev you need it actually. But I'm not a full stack web developer, so I can't tell you for sure. I'm from Austria. I hope my English is not too bad. The stream is for me is one motivation for the stream is to learn English, to learn speaking English. You're from India, cool. So actually, I think your college is doing well. Sometimes I had university too. I finished university or University of Applied Science. It's different in Austria, and yes, some lessons are cool and some lessons are interesting, but some lessons are not too interesting. So you have to learn. Sometimes you have to learn stuff that's a bit boring. My state is backward in IT sector, so yeah, they don't teach new technologies. Yeah, it's actually quite hard. It's quite hard to keep up because there are so many. Every week you have new services, so there are some fundamental things you will learn even if you use outdated technologies, like yes, the fundamental stuff like locking stuff or something like that. It's stuff that is fundamental, is affecting all the technologies, and if you have seen the behavior in one technology, it's fine. If you have a different interface, a different commands in newer technologies, then it's okay. I'm confused. Sometimes I want to be web developer, Android OS developer. Sometimes I want to be game designer. Yes, I understand. It's hard because you will realize that you can't save the whole world. there is too much to learn out there. We live in a time you can't learn everything. I would like to do so many things as well, but the day only has 24 hours, and I guess even in India it's only 24 hours a day. In Austria it's also 24 hours we have, and you need a lot of sleep, so that's all we can do. So let's see if we have what's your point of view on new JavaScript libraries and frameworks comes hopping every month? Yeah, the JavaScript community is making fun of themselves as well in this topic, because it's quite ridiculous because there are so many frameworks. I heard people saying, please don't make another JavaScript framework. Yes, it's I think actually it's fine. It's fine. If people make a lot of libraries, just copy and paste React and make it as yes. I think it's okay because one advantage of the Linux system, I'm using the operating system Linux here, Ubuntu, the distribution Ubuntu, and one advantage of Linux is there are so many little tools. And if you have a lot of libraries in JavaScript, then you have many libraries to choose from. And if a library is actually very good, then it gets popular. And so it's cool. I think it's fine. The best libraries will become popular, and the other ones it's hard to compete, of course, because there are so many out there. But so let's make 80 connections. That's interesting. Svelte is becoming popular. No, I don't know the JavaScript libraries because I can't code in JavaScript. Svelte JavaScript. Kybernetically enhanced web apps. I don't even know this is the node package manager, but I don't know how this is working. You can Can I do this on my PC? Let's make a test. Yeah, no problem. No problem. It was nice to see you. I will try this and then. Then it's time. Need to install the following packages. Create Svelte viewer. Proceed. Why not? Unexpected reserved word. Okay, good night. Good night, Svelte. No, I don't know. I have a policy. If the first command I'm writing, I hope you achieve great success in your programming software engineering career. Thank you. I hope you too. Good night. So interesting. That's interesting. It looks like we have 44 connections because yes, 44 connections. 44 connections because everything else socket closed already, shut down. Bye. Thanks for the follow. And see you next time. Okay, receive failed, connection error occurred. Okay. Yes, that's okay, that's fine. Receive failed, connection error occurred. Okay, but I don't see any error. Why? What is happening? We are that's different. We are connect. This is on line 231. Connection main. Okay, we connected already, but I guess the buffer was too. Can we flush a socket? Can we flush a socket? No, see. Come on. Is there a way to flush a POSIX socket? You can, for Unix domain sockets, you can use a flush, but I'm thinking you probably mean network sockets. Yeah, there isn't really a concept of flushing those. The closest thing are at the end of your session calling on to close out threads on the socket. Disabling the Nagel algorithm with a socket of no delay. which is generally a terrible idea that will not reliably do what you want, even it seems to take care of it on initial investigation. It's very likely that handling whatever issue is calling for a flush at the user protocol level is going to be the right thing. Okay. Push, however, there is no TCP that implements push. No luck. To put it differently, TCP will send the first packet of a row packets immediately, only if the connection is slow and your computer does not get a timely acknowledgement. NAGL will delay sending subsequent data until either, whichever occurs first. Timeout is reached. The last unacknowledged packet is acknowledged. Because we are not acknowledging the stuff. Your send buffer is full. Okay. Oh, come on. Oh, I need another beer, I think. So, cheers. Jeg shake it. I hope this is. I hope this is a good one. I don't think so. Oh. So. Yes, one problem we have is here in the server. That is the telnet filtering, I think, is not. I hate this behavior. So, we have a telnet filtering read. mpcon key get. Okay, in the key get, yes. Size of buffer. Key received. Yes, we have to make a state machine. Yes, I have to. Because we have the SSH filtering as well. I think, yes, SSH filtering. And here we have the same thing. Key get. And yes, that's it. Data process. What are we doing here? Data process. Yes, we get one packet, message channel data. Okay, buffer fetch. Oh, okay. We get the header of the SSH stuff, of the SSH layer, and then we have the string. We receive the string of data, receive channel data, stuff, blah, blah, blah. And then we go to key get. And then we have the state machine. Okay, the filter. Let's see how we are using the filters. For example, in game creating, key get. Do we have a key get? No. Okay. We push it into the pipe. Okay. Yes, p keys. We have we push it into the pipe. So here we have the key get. Yes. And if we get the key, then we commit something. And this thing is what we see. Data received. In the telnet filtering. Okay, if we have received a lot of bytes, then we are not responding. I understand. Yes. We need to. Yes, we need to implement the key get function. State machine. Key get. That's strange. I have data process. I have to call this thing data process. Okay, let's implement the stuff because we need it long time ago already. Okay. Bah. So, come on. Okay. I have to take a sip because yes, okay. Come on, let's do it. We have a new function that is called data process in the telnet filtering. Somewhere the data process function must be executed. I guess that it is executed somewhere in the main filter. Yes. If data process is not pending break, that's fine. We have the same here. That's cool. And now we will move the function from here properly to here. Yes, that's cool. What? Why? Success. That's cool. In the data process we have to return pending. If not pending, then break. Positive. What? Why? Data process. If not pending. If not pending, then break. Yes, because we have processed something. Yes. If we have processed something, then yeah. Okay. So we have say positive. And here, yes. It's fine. I think that's fine too now. Now we can compare. this thing, yeah. If we say num bytes read, we try to read something from the socket, and if we did not get anything, then we return pending. Yeah, we have to be careful. If not buff. What if we have an error? We can say yes, I think that's fine. Oh, yes. Okay, I think that's fine if we do it like that. So we have a buffer. We have some buffer. We say, okay, buff fetch. If not buffer, then couldn't fetch channel data. Oh, no, that's not what we want. Here, that's it. P key. Yes, I think that's fine. So we have a P key as well here. Data process, P key, P buffer. We have a buffer and a P key. Yes, that's cool. What we have here in the string is here in the buffer. Okay. We don't have a key user. We don't need it. This is, I think, in the key get function. No. Okay, whatever. Let's keep it for a moment. Key user. What is key user? Come on. Key user is buff 0. And then we return key. Key get. Key get, and that's the key user. And yes, we are committing here. And what do we do here? Key. Oh yes. I catch the mosquito. Okay. I see some bad thing here, I think. Because our key is not uinteger8. Or is it? Yes, it must be at this point. Yes, it's at this point it's uinteger8. Key get uinteger, that's fine. 8. And here we have the same, I think. Yes, that has a different, yes. A different meaning at the moment. But we have to make it the same. Okay, that means we have to change the function. Yes, we want to produce a key user. But here we only get in integer, in character. Okay. Now this is fine. Let's keep the old definition here at the moment. Telnet filtering. Let's not keep it here, but here. Key get. That's the new definition we need. And that's the old definition. Yes. That's fine. Okay, poo. Now, at this point, it's like we are in this case. This means if we have size of 1, this means if is this usable. What is key escape? Key escape is TGS key escape. Yes, that's 1 byte and that's fine. So I can copy this code and say if num bytes read is 1 and and p key is equal to buff. That's fine. And if the pointer to the key is key esc, then we say key esc and committed and positive. Yes. Otherwise, we make this, which means poo. For size 1 to string size, this means num bytes read 0 1 from 0 to fine. Success is key get. That's fine. Now we have the state machine in here. That's cool, I think. Way better. Here we say if the number of bytes. No, I don't care. I don't care at the moment. I just want to do this. Yeah. At the moment I want to do this. If we have received something, then we say if 1 and if data received, length num bytes read, buffer num bytes read. Okay, so we print everything. That's cool. What is D? If buff 0 is D, then num bytes read. Yes, whatever. Can we use the same state machine here? I don't know. I don't know. We just re-implement the whole behavior. Okay. And then later we can optimize the stuff. But now we just copy all the stuff we have. Okay, key get. Data received, we don't need this anymore. If D. Yes, I understand. A, B, C, D, key left. No, but not in this case. Key is user disconnect. Key is user disconnect. Oh, that's an interesting function. Why is this happening? Control D. Key enter. This is key enter. Oh yes, I understand. Key enter. Do we have the same here? Key enter. I have to open again the SSH filtering header file because we have a key state. A state key now. Again, and in the main we have the telnet filtering. I have to fix this as well. This is so annoying. Okay. We have a state and we have a state key. Yes. Or byte check key commit. Oh yes, we have a define here. Nice. Key main, okay, that's interesting. State, here we have state key main, that's fine. And now we copy that stuff. Keys, yeah, that's cool. SSH field state, key state. Let's do it like that. Proc state, yes. Oh, that other one is an old process. Okay, let's remove the stuff for one moment. We have a state key. Telnet filtering, yes, fine. It's getting better and better. Key received, yes. We don't need any of this now. We can remove this and your num bytes read. Enter, yes. Key is user disconnect, so we just have to check everything later on. Okay, that's it. That's it. Okay, we copy the stuff on the bottom. Key get. Yes, and at the front. Perfect. Yes, fine. That's cool. Key state 1. Yes, key received. Key, yeah, yes, okay, fine. I think that's good enough for the moment. Oh, we have to switch to the server entirely at the moment, or I'll leave this open. That's okay. I make a split. Ninja. Yes. Oh, that's cool. No matching function. That's fine. Key get. Ah, yes. If not key, yes. Key commit. Perfect. Because now it's the same. Data process. Nothing is happening if I... Yes. Okay. Key unused variable key. Key get. Ah, okay. Stop. Okay. Was not declared. Come on. P key. P key. Const char buff. Yes, fine. Nope. And SISD, size T and SISD, yes, okay. Success. Key get. Oh, that's in the SSH filtering. Success. Ah, yes. One moment. Here, P key. Success is success. Return if pending, continue, otherwise yes, state, we don't have an SSH state field the init. We can say an telnet field the init. Oh, telnet field the init, that was cool. And telnet what did I see? Though a state telnet the init. A state is what? Okay, this is a very, very old class. Okay. Main and then the init is show cursor. Yes, fine. Okay, that's perfect. Could not get key and then we have the init. Yes. Outside of class is not definition. What? Ah, yes. Was not declared in the scope. State string. Telnet filtering. What? Proc state string. Okay, perfect. Now it's working. Fine. Ah. Come on. Verbosity 4. Let's make a verbosity of 4. I want to connect to the server. This means I have to split again. I have to split again because I want to connect in one window. Yes, fine. So that's better. Here I want to split horizontally. Yes, okay, that's fine. Now it's fine. Okay. Okay. NC localhost 3000. That's cool. A little bit bigger. Okay. Telnet localhost 4000. Now, and that's perfect. We have a telnet filtering process. Oh yes, that's cool. Selection done, wait. We received some key. Telnet filtering. Data received LAN 6. We have received some stuff. That's a telnet related. That's a telnet related stuff. Okay. What is happening in key get for SSH case? Key escape. What is key escape? One B. Okay. Let's check. Now we need the RFC. The RFC is for telnet. In the documentation we say telnet. And we need the telnet RFCs. Oh my god, that's so many. Telnet protocol specification. Obsoletes. Print and keyboard. Form feed. Blah blah blah. And erase line. Okay, code. 255. The following are the defined telnet commands. Note that these codes and code sequences have the indicated meaning only when immediately preceded by an IAC. Interpret as command. Telnet command structure. All telnet commands consist of at least a 2-byte sequence. The interpret as command, EAC, escape character, followed by the code for the command. The command's dealing with the option. Okay, so this is only The SSH we have, yes, that's perfect. This one is fine. This one is fine. Okay. What else do we need? Option specifications, echo options will... Echo options will... Up. Okay, let's see. We need at least a key interpret as command. So we have a state interpret as command. Okay. Can we... Oh, that's... Oh, hopefully. Okay. We have key main. We have state key EAC. Interpret as command. That's fine. We say define. Define key. Interpret as command is 255. Key get. Key get. Key main. If key is equal to key IAC, then break and go to M state. Key is equal to ST key EAC. Is this? Yes, that's correct. And we can make a warning, for example, for debugging. Command telnet command received. Thank you, compiler. Okay. Telnet command received. Okay. Now we are in the state IAC. Interpret as command. Okay, now we have to interpret the telnet command. What is this thing telling us? It's telling the next one is FD. What is FD? FD is... come on. FD. FD is equal to 253. Do. The do indicates the request that the other party perform or confirmation that you are expecting the other party to perform the indicated option. Oh, okay, again. The do option code indicates the request that the other party perform or confirmation that you are expecting the other party to perform the indicated option. I don't get it fully, but I will make another state. Key do. And we say if key is key EAC do. FD. Then come on. We are in the state EAC do. Oh, come on, another mosquito. The hell. Okay, if we interpret something and we get a do command, then we get into the state do. We connect IAC, interpret this command, and do something. What should we do? Key IAC do what? One. Do one. Okay, let's read again. And at least of a 2-byte sequence, the interpreters command escape character followed by the code for the command. The commands dealing with option negotiation are 3-byte sequences. Okay, 3-byte. The third byte being the code for the option referenced. This format was chosen so that a more comprehensive use of the data space is made. By negotiations from the basic NVT, of course, collisions of data bytes with reserved command values will be minimized. All such collisions requiring the inconvenience and inefficiency of escaping the data bytes into the stream. With the current setup, only the IC need be doubled to be sent as data, and the other 255 codes may be passed transparently. The following are the defined telnet commands. Note that these commands and code sequences have the indicated meaning only when immediately preceded by an IAC. Okay, we have do indicates Do we have a list of options somewhere? Option specifications listed from telnet. Do ABC request for to use option ABC for favorable acknowledge and other parties. Yes. Mr. Postal. Command name and option code. Command meanings. Subnegotiation section. Page 3. PDF. Download. Move RFC whatever to here. Okay, it's still only 3 pages. Telnet options. Echo. RFC 500. Okay. This is the echo option. Echo command name and code. That's cool. PDF. Move. Okay, so the echo option. Host on the echo command meanings. ISC will echo, do echo. The sender of this command requests that the receiver of this command being echoing, or confirms that the receiver, the sender of this command, the sender of this command requests that the receiver of this command being echoing, or confirms that the receiver of this command is expected to echo. Yes. Data carried is received over the telnet connection back to the sender. Yes, okay. So I confirm the echo. Filtering. Key echo. We could say RFC 854, and this is as well RFC 854, and this is RFC 857, I think. Yes. And in the do, we can say if key is equal to echo, then key state, it is done. We can go back to state key main. We just ignore this message, we accept it and ignore it. Command received, and yes, now we got another command and we have a do, and that's the, oh, that's cool. So now we need another RFC. That is, oh, we get the telnet options as link because this is annoying. 3 suppress go ahead, so that's cool. We want a PDF. We want to save this PDF. And that's fine. Telnet filtering 58. Yes. Key suppress to go. Suppress go ahead. Ah, come on. If key is equal to, then it's fine for us as well. And everything else should be a key. How can we commit the key? Yes, by the main. Yes, if we do this, key commit. Every other key is a key commit. Yeah, okay, that's cool. Sounds cool. In which we are in the state key main. That's very important. That's cool. Because we have received 2 commands. Key received. Yes, that's fine. Now, if I press C for create, oh, then it is working because we have committed the key. That's very cool. If I press key escape, it's working. Whoa, that's cool. If I press Ctrl C, it's not working because because I have to check the special case. Key is used disconnect. Then I have to say state telnet the init. If I press Ctrl C, it's working. If I press Ctrl D, oh, it's working. Mwah. Ah, a bot connected or somebody else. And now I see the commands. And if I get something else, I say if I get something else, then I don't like this code. If I get a do command, I don't know, which I don't know, then I say unknown do command option. Unknown do option, which is key. And then we disconnect immediately. That is quite cool. Only known commands are permitted. We are getting these two commands because I send these commands. I say I will echo, and the client is sending an acknowledge because I sent this wish that I will echo, and I will suppress the go ahead, and I won't do the line mode. Hide cursor and this. It's strange that I don't get anything like this, but okay. It's not sending. It's not sending this. Okay, whatever. So that's cool. So that's very cool. If I press now all the other things. What if I press left? Ooh, I pressed left, and this thing thinks that I'm escaping because I received these 3 bytes. What is this thing? Yeah, escape. Yeah. Oh no, I just need to. Oh, yes, I just need to. Stop. The init data process is success, and in the data process, if this is not positive, then we make an the init already. So I just have to say return proc error log -1 unknown do option. That's cool. So then I have key this I catched it and I released it. Oh, come on. So escape main. Key escape main, that's cool. Oh yes. Key escape main. Yes. If we get a key escape, yes, first we will interpret all the low-level stuff, that is the telnet key interpret as command thing. If the key is escape, then we check the escape main. If, I guess this is a bracket, hopefully. Oh, I got 22 key received. That's cool, that's cool. I have to check this. Oh, that's cool. That's very important. That's good. That's exactly what I was missing. Okay, slow down. Let's try this and this. Key escape bracket. Okay. We got F, and C. F and C is defined here, I think. FC. Boo. That's the suppress. Go ahead. FC is want. Yes, want. That's perfect. That's perfect. As expected. ISC to define key ISC want FC RFC this, and then we say define key whatever in RFC unknown at the moment. Cool. So we look at the list again. Telnet options 22 subtube output. I want line mode. FC22 FF FC22. That's correct. Line mode. Why is okay. We have different telnet authentication types. Yes, that's different. Line mode. Yeah. Okay, we don't need this one. We don't need this one. This is finished. Line mode option. What? Okay. Line mode option. Want line mode? This line mode. Okay. What character? What code is line mode? Line mode is yes, hex 22. Okay, that's correct. That's fine. That's cool. Yeah, perfect. And 1184. 1184 key line mode. Perfect. So we have the key interpret as command, and we have the want an unknown want option. If key is equal to key line mode, then we say that's fine for you. That's all the telnet low level stuff we need. Okay. We say if escape, then we hope that something is a bracket. Okay, Control C working, Control D working, escape working. Key received should not work like this. Data received 1. Yes, because it's short circuit. Yes, if the size is only 1, and if the size is 1 and if we have an escape, then it's interpreted as escape, and that's fine. Yes. Yes, that's cool. That's perfect. Now we are in the state. Yes, we are in the correct state. Key received. Yes, that's cool. So I think now check the up down key. Ooh, that's cool. So this is the VT. I think this is the VT 100 stuff. Ooh. Yes, whatever. I will. Yes, that was key left. Check and commit. Byte check and commit. Yes, that's fine. Okay, let's copy all the stuff. We can improve the code later. That's all the VT100 escaping. Yes. Key in state. Then we need a key escape 1, it seems. And we need a key escape 2. And a key escape 3. And then key escape tilde. And that's it, hopefully. What, 1, 2, 3, yes. Tilde. Okay. Escape 1, 2, 3 and tilt. And now everything should work out of the box. Now let's check. Oh, now it's interesting. Telnet localhost 4000. I want to create the game. I can make test. Now I should be able to. Oh yes, it's all perfect. That's so cool. Everything working like a charm. Yes, cool. I want to check something else. Oh, this is working as well. Oh, yes. Okay, that's crazy. That's so cool. Version history. That's correct. That's not correct. That's correct. That's correct. Why sometimes it's not working? Page up and down must have the same. Capital J and capital K are working completely. And page up and down should have the same meaning. Whatever. Whatever. Okay. So, but this is fine at least. Oh, again, I have to see it. Up and down is working. Position 1 is working and is working. What else do we have? Yeah, I don't know. Okay. So cool. So cool. Okay. We changed a lot today. Whoa. Okay, RM TGS test. TGS testing. These two files are not needed. Okay. This means we have here's now. Okay, let's commit stuff. TGS not documentation add telnet RFCs. Fine. Okay. Ja, genau. Yes. No. Git add p dot. Move connect for to first place. So in the telnet filtering, yes. Implement key state machine. That's cool. So now we have to add this information in the history and say the second version in July has telnet support arrow keys. Yes, cool. Now, we have to release this version today, because this is a very cool improvement. That's a very cool improvement. Cool. And now we can continue with the testing stuff. Because now we have interactive testing, CPP. We need menu interfacing, I think. We need yes, we have a different telnet filtering process. I should be able to just I should be able to use the new one. What did I change here? Whatever, let's see if we can just replace the telnet filtering. Yes. Oh, cool. Now, whoa, perfect. So, now we can move our arrow keys up and down with the, that's so cool. This is a little bit too verbose. We have too many. I don't want to have, yes, so many. Yes, all of these comments are not desired. Okay. Telnet command received, yes. Telnet command received. Telnet filtering and main telnet cool. Now back to business with the testing. We have our server, and the server is, yes, we need to compile it again. We have the number of gamers, number of connections. We want 80 connections with an interval of 1000 at the moment. And we try to connect. $80 connections. Okay. Okay, at the moment I don't want to see the game interacting process. Oh, now we should have all shutdown closed already. This thing should go to 0 now, I think. Game interacting is not shown at the moment. In the game interacting create. Come on, create, perfect. Start. if it's local, then true. Only if it's local and local connected. Okay, I need another. Okay, member variables of what? We only have 2. That's okay. Bool local connected. If count local and then true and local connected is true. If not local connected. Yes. Perfect. Now I restart the server. I connect. I should see myself. That's perfect. But now if I connect again, every process has been cleared now in the testing process. That's fine. But now if I connect, then I only see myself and I see that the connection count is going up. We see that we receive a lot of stuff. Oh, this is so cool. Now I can navigate up and down with the arrow keys. Cool. And we have to encapsulate all the VT100 command stuff. And that's all. That's everything. Okay. Now we can check what is happening. We see that the testing process thinks that everything is fine. The server okay, we remove game selecting this message, server list, getting server list and got server list. Everything is shut down. Yes, continuing to server selection. But that's always a different process, I think, that is shown. Okay, I have to restart the server again. 1, yes. Start again. Okay, we see everything. Every time another process is connecting. These processes have a finished connection because the TCP listener is telling. Okay, whatever. I don't know, but we are a big step further today. What can be happening here? Do we have any restrictions? Let's see. Port set TCP listening. That's the telnet listening process. And the telnet listening core telnet listening process. Max connections. What is the default of max connections? Yes. Max con. PFDs and max con, yes, but we are removing the stuff. So it's fine. If the queue is bigger than max con, haha, let's see the size of the connections created. Queue. Okay. Connections created. Queue set U. Okay. We need to show the listening process in the dispatching. Okay, this is the telnet listening process. Yeah. This thing shows us how many connections are created. Yeah, that's cool. Yes, now we have a listening. Oh, come on. We want to have this beautiful. Perfect. First one. Nothing in the queue. One connection created. Con created because after we say got socket file descriptor. If it's full, then Okay, cool. And I say that timeout okay. Timeout okay if if something, yes, I want to see something else. TCP listening. Statistics. I say bool con pending. No, con pending, yes, maybe. Con pending is true. Otherwise, invalid socket. We were not able to accept. If we were not able to accept, then we removed the thing already. Yes. Okay, count pending. Count skip. Connection pending false. Q the info. Connection pending. Yes, I think that's it. Okay, Q. Connections created, connections pending. Oh, that's fine, that's cool. Oh, yeah, compiled. Yes, connections pending, no Q0. Connections pending, ho. Connections created, connections pending, no, nothing in the queue. Interesting. So the TCP listening process is not the bottleneck. It's not the reason why we don't get anything. Now we know. Okay, that's an improvement of the TCP listening stuff. Okay, we have connection pending, true, false. Improve debug output. Cool, very cool. Okay. So next one. So this is not the bottleneck. Let's keep it for a moment. Okay, menu interfacing. Okay, we are at the end of our stream today. I think we have coded a lot again. Let's see how many lines. We are at 24K already. That's quite cool. And it's quite fine. TCP transferring, telnet filtering. Telnet filtering is fine. Where is SSH filtering? SSH filtering is too big. Yes, we can remove some code from both of them. So these two needs to be improved and refactored a little bit, but it's quite okay. Okay. Listening. So let's rate somebody. I hope to see you next time. Next time is on, yes, next week. Maybe we have a special streaming day next week. I will add this to the schedule, the Twitch schedule, and hopefully we will see you. Twitch, who can we rate? Poster is always working. Jessica Mark, is she coding today? Oh yes, she has a very cool. Okay, the title is the title is quite strange. Let's see what she is doing. Join with me rating Jessica. She is coding a cool game which is synchronized with the music. So bye everyone. Hope to see you next time.